use those to be able to solve the equation. The directions here say to write the general solutions and solve each equation on the interval. Okay, the interval is either going to be 2 pi or 0 to 360. You will never do both. The problem will either tell you, or there will be a C value where there's either a degree symbol or there's not. All right, so this first one, 3 sine squared x minus cosine squared x. When you look at that, a lot of you think double angle. Well, there's a 3 here, so that throws out the double angle. Okay, so we cannot use the double angle on this one. So it has to be Pythagorean. You like sine squared better, you like cosine squared better. Whatever you like, use that one. So our Pythagorean ID is sine squared x plus cosine squared x equals 1. So no matter which one we pick, we have to plug it in. We're going to either replace sine squared or we're going to replace cosine squared. It doesn't matter which one. I like sine better. Okay, so I'm going to replace cosine squared with a rewritten Pythagorean ID here. So 3 sine x minus. Now I am changing a single word into 2 words. So I have to use parentheses. And that's going to be 1 minus sine squared x equals 0. Now I just need to distribute. And now all I'm doing is adding and subtracting like terms, getting things all on the same side. If there's just a squared term when I'm done, then I can solve using square roots. It all just depends on what is happening here. All we have is a sine squared. So 3 plus 1 is 4 sine squared x. Because there's no sine x, I don't have to worry about factoring. I can just bring that 1 over and solve. Divide by 4. Has anybody ever remember what you do when you take the square root? Maybe we remember that now? Plus or minus, and we won't ever miss that ever again. Sine x equals plus or minus the square root of 1 is 1, square root of 4 is 2. When you take the square root, it is plus or minus. Now, depending on the situation, you're studying for your final exam and we're looking for the length of the side of a triangle. Are we going to use the negative? No, it's still plus or minus, but you don't use that depending on the situation. Here, we're just finding where does this happen, so we're going to use it. All right, so this problem, let's see, what does it say? This tells us right here that we're in radians. So we got to figure out where that happens. Well, that's going to happen at 4 places. 2 quadrants it's positive, and 2 it's going to be negative. And it's where y is equal to 1/2. So that's going to happen here, 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 and here. All those places. So our general solutions. X equals pi over 6 plus the period. This is where we figure out the period. We don't know the period of a squared function. I don't even know if it has a period. The period is b is 2 pi over b, which is 1. So it's just plus 2 pi n. And we have 5 pi over 6 plus 2 pi n. And we have 7 pi over 6 plus 2 pi n. And 11 pi over 6 plus 2 pi n. Now, if you're one of those people that wants to simplify that, because you can notice that answers happen every pi, so if you want to just do pi over 6 plus pi n, pi over 6 takes you here, so you can mark out that 7 pi over 6 if you say plus pi n. And 5 over 6 plus pi n will take you to 11 pi over 6, so if you want to simplify that, you can. You can have just these two plus pi n. You don't have to do that, but if you want to, you can. All right, then the second question says find all answers between 0 and 2 pi. Well, we just did that. So letter B is going to be pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. Always pay attention to that domain when it's asking for the domain. Be sure you pay attention to the domain. Draw out a number line if you need to, especially if it's maybe like a positive and a negative. draw that out so that you don't include ones that are too big or too small. Here it's pretty easy because we know not to put any negatives, and then we just go to, if we have a 6, we go to 12 pi over 6, because that's 2 pi, and we're done. All right, sine 2x equals negative cosine x. Now yesterday we had a problem like this, sine 2x equals negative 0.21. It was a calculator problem. Then number 3 or 4 was sine 2x equals root 3 over 2. We can do that. But now it's sine 2x equals negative cosine x. So now it's a different problem. We can't do this problem and have a 2x and a 1x. We can't do anything with the period yet either. We can't say I'm confused about the period because one of them's 2 and one of them's 3. We can't state that yet because we don't know if our angle is going to be 2x or it's going to be 1x, the 2 or the 1. So we have to use our identities. Only way to do this one is to expand this. Now the other day we had cosine 2x that we had to expand. Now we have sine 2x. It's easier because there's only one. It is 2 sine x cosine x equals negative cosine x. You cannot divide by a word. You cannot divide by a letter. You can only divide and get rid of numbers when you are solving. If you get rid of letters or words, you're getting rid of solutions. Maybe 1 or 2 solutions, maybe half of them, maybe all of them. So do not ever get rid of words. Ever, ever. I've never gotten rid of words when I've done the examples, so you should not do that either. It is not correct. You have to bring all the words to the same side. Now, when you have multiple words, there's a couple different situations. Either you can use a Pythagorean to make the words the same. Does this have anything to do with Pythagorean? No, there's nothing squared, so it's just a GCF. Eleanor?
When you say get rid of words, do you just mean like
cancel them out. Cancel. You cannot cancel out words. Okay? Cancel, reduce, simplify. You can't get rid of them. They always have to be there. So we have a cosine and a cosine, so it's just a GCF. We can factor out a word, but we can't divide it out, get rid of it. So we're left with 2 sine x plus 1. We can't get rid of that space either, because factoring is just if I factored it back in, distributed it back in, I would get what I started with. If I had x squared plus 3x, or let's say 3x squared, and I brought out a 3x, that doesn't, does that equal that? No. Plus 1, now this equals that. All right, so now we have our 2 factors. This is called the zero product property rule. We can't set that equal to anything other than 0 to solve it when there's multiple words, more than just a sine squared or a cosine squared, or cosine. So we can say cosine x equals 0, and 2 sine x plus 1 equals 0. This is where we can determine our period. Now that the word is by itself, we can determine that. So our period is going to be 2 pi over b. b is 1. So our period is just going to be 2 pi for when we write our general solutions. If you need to go one step further here, inverse cosine of 0 equals x, then go ahead and do that. Think about your unit circle. Where is x equal to 0? There's 2 places there. So we can say x equals pi over 2 plus 2 pi n, and x equals 3 pi over 2 plus 2 pi n. Or if you were one of those that likes to simplify it, x equals pi over 2 plus pi n. Because these are the same distance apart this way and that way, you can simplify it. When they're not the same distance apart, you can't. Now, that's just part of our answers. We still have to figure out our answers over here because this is still all the same problem. It hasn't turned into 2 separate problems. It's just 2 separate parts of one problem. We are still solving this same problem. So here we have sine x equals subtract 1 divided by 2. Where does y equal negative 1/2? 2 places right there. So that's going to be at x equals 7 pi over 6 plus 2 pi n, and at x equals 11 pi over 6 plus 2 pi n. So there are your general solutions for this problem. All of them. Not part of them, all of them. Now, this question doesn't say it, but it could say, find the first three positive. It's not find the first three positive of part of it and first three positive of the other part. It's the first three positive of the whole thing. So the whole thing would be pi over 2, 7 pi over 6, and 3 pi over 2, if that was a question. Okay, it's not of each part. Those are the general solutions for this problem. So then letter B, find everything between 0 and 2 pi. So x equals pi over 2, plus minus the period too big or too little. 3 pi over 2, plus or minus the period is too big or too little. Same thing with 7 pi over 6 and 11 pi over 6. Only time you would have to worry about there being additional solutions between 0 and 2 pi and 0 and 360 is if the period, the b value changed. If the b value doesn't change, then once you found your general solutions, as long as you didn't simplify them, you have all those answers in that specific domain. All right, so here's one like yesterday where we have that angle. Sometimes that angle messes with you. That 2x is just attached to the cosecant. We got to deal with that cotangent also because those words aren't the same. So if the words aren't the same, then we cannot do anything until the words are the same. There is no way to change cosecant into cotangent. We have to change cotangent squared. That's the only one that we can do. There's nothing else though. Like the first one, we could decide what we like better. Here we can't decide. We have to change cotangent to cosecant. This tells us exactly what the word needs to be. So that ID is cotangent squared x plus 1 equals cosecant squared x. Therefore, cotangent squared x equals cosecant squared x minus 1. That big packet, we said rewrite this. This is why. You've got to be able to rewrite it, rearrange it. So whatever that angle is, this could be cotangent squared a equals cosecant squared a minus 1. In this case, cotangent squared 2x is our angle, cosecant squared 2x minus 1. So whatever that angle is, you just replace it. It can be anything. We have put so many different letters and angles in for you. Theta, alpha, capital A, lowercase r, t, f, c, all of those different things you could have there. So this is going to be 2. We're changing one thing into 2. Okay? Right here, this is what we're replacing it with. So cosecant squared 2x, not a parenthesis there, minus 1 minus 3 cosecant. Now I'm just rewriting what's already there, bringing it down. All I did was substitute right there. Pythagorean and double angle. You need to know your Pythagorean, you need to know your double angle. So now I need to distribute 2 cosecant squared 2x minus 2. Some of you could do like the distributing and combining and leave that step I just wrote out. That's fine. So combine like terms. Only like terms we have are those numbers. We cannot bring the numbers to the right like we could in number 1. Number 1, we could bring the numbers to the right because all there was a squared, and we could solve using square roots. We can't solve using square roots when there's something squared and something unsquared. Our only choice is to factor. So 2 cosecant squared 2x, that's just our angle, which is going to affect our period in a minute, and then plus 1 equals 0. A squared, an unsquared, and a constant. That's just factoring. 2 parentheses equals 0. Only way to split this up is to 2 cosecant 2x, cosecant 2x. Only way to split up a 1 is a 1 and a 1. At max, you would have 3 maybe possibilities as far as these problems go. Nothing more than 3. Doesn't mean they're not out there, but we're not going to give you some crazy factoring problem to do. You'll have plenty of that to do if you take calculus. All right. Negative, negative. We need a positive 1, so the signs are the same. We need a negative 3. 1 is in the inside, 2 is on the outside. So now we can set our two factors equal to 0. Whenever you have two factors, they must be equal to 0. Zero product property rule. No such thing as anything other than the zero product property rule. So we have 2 cosecant 2x minus 1 equals 0, and cosecant 2x minus 1 equals 0. Add 1, divide by 2. Here. So again, this is where we can determine our period. Our period is going to be, can't remember if we're in degrees. We're in degrees. Okay? So our period is going to be 360 degrees divided by b, which is 2. So our period is 180, which we are going to need to know in this problem because we have to write general solutions. Now remember, if you don't like cosecant, you like sine better, take the reciprocal of the left equals the reciprocal of the right. Can that happen? No. So we're done. We get no solutions from that one. So we go over here. Cosecant. I still don't like cosecant, so I'm going to change it to sine. What's the reciprocal of 1? 1. It's the same. So we can say the inverse sine of 1 equals 2x. So where does y equal 1? Where? 90 degrees. 90 degrees equals 2x. Divide by 2. X equals 45 degrees plus the period we already found to be 180. And it's at a top or a bottom. When sine or cosine equals 1 or negative 1, there's only one time that happens. Then for letter B, how many answers are we going to have? Between 0 and 360? 2. Because 45 plus 180, we have to add and subtract the period until we're too big or too small. Subtracting too small, we can go one more time and still be between 0 and 360. Remember, when that period is not 360 or 2 pi, and we're looking between 0 and 360 or 0 and 2 pi, then you're going to have more than just those solutions. So you have to add and subtract the period till you're too big or too little. All right, still have that angle in there. We have a root 3 and a 2, which sometimes looks scary, but we have a root 3 on our unit circle. We have a 2. So we need to, those numbers are okay to have a root 3 and a 2. This is not like the last one because there's no constant. So it's just a GCF problem. We have a square, we have a cosecant squared and a cosecant. So all we have to do is take out a GCF, which in this case is cosecant 3x. That leaves us with root 3 cosecant 3x plus 2. So now we have our two factors. Cosecant 3x equals 0, and root 3 cosecant 3x plus 2 equals 0. So let's say we don't like this, so we want to take it. So really, that's going to flip and be that. Is there anywhere on the unit circle where sine is undefined? Think about that curve. Is there any kind of asymptote or any kind of undefined? No, sine is never undefined. Cotangent is undefined, tangent, secant, and cosecant, but sine and cosine are never undefined. There's always an x and a y value. So therefore, this one, there's no solutions, which also tells us cosecant and secant can never be 0. Because really, you're looking for where is y undefined? It's never undefined. Everywhere on that unit circle, there's a y value. All right, so over here, subtract 2 and divide by 3. Cosecant 3x equals negative 2 over root 3. We could also determine our period right here, 360 over 3. So the period is 120 degrees. So at this point, inverse, no, let's change it to sine. I don't like cosecant. I want to make it sine. We could say sine of 3x equals negative root 3 over 2. Now, you don't have to write that. If it's helpful, write it. And then the inverse sign of negative root 3 over 2 equals 3x. And so we're looking for where does y, there's two places. Where does y equal negative root 3 over 2? That's going to be down here at 240 and at 300. So we have 240 degrees equals 3x and 300 degrees equals 3x. So for our general solutions, divide by 3, we get 80 degrees equals the period. We already found that to be 120 plus 120 degrees n, and x equals 100 degrees plus 120 n. And there are your general solutions. Remember, we could have gotten up to 4. We could have gotten 2 from this and 2 from that. 1 from each, 2 from each. None in 2, none in 1, all kinds of different combinations. Letter B says find all values between 0 and 360. So let's start with 80. 80 is, we subtract the period, we're too little, so we don't have to worry about subtracting. Add the period, plus 120. We get 200. Plus 120, 320. Plus another 120, too big. So we're done with the 80. Then we go to the 100. Subtract too little. Add 220. Add again, 340. Add again, you're too big. So there are all your answers between 0 and 360. If this had said, find the first 3 positive, 80, 100, and 200. All of those different possibilities you can have.